Hello, Mr. Stone here, and we're going to talk today about dilations. So, dilations really are just a way of scaling an object, making it either larger or smaller. If we're going to make an object larger, then we can simply uh, multiply whatever our side length is, or whatever the coordinate is. So, let's take an example here. So, let's say I've got this triangle. Ooh, what do we notice about this? There's a 3, 4, 5 triangle. We've seen that guy before. So I've got my right triangle here, and let's say I want to enlarge it by a factor of 3. So I'm going to do a dilation, and I want to keep it centered here on this point A. I don't want point A to move. So all I need to do is take my point here that is C. I'm 3 units away. Now I would go 9 units away, because 3 times 3 would be 9. If you're using GeoGebra, there's also a really powerful tool. You can just do dilate, and I'm going to dilate this point C, and I'm going to do it by a factor of 3, and I'm going to do this to around my point 1, 1, which is A. Boom, there you go. C has been dilated. It is now C prime. And if I make a segment from A to C prime, we see our new segment D has a length of 9, which is that scale of 3 that we wanted. I can do the same thing for B. So I want to dilate B by a factor of 3, and I'm going to still do that from my point 1, 1. Because I just want to make a triangle that has sides 3 times the length. So check this out. If my original side here, this side was A, that has a length of 4, and it goes up to the point 1, 5. First of all, what do you think your new length will be if the original length was 4? We're multiplying by a factor of 3. Okay. And where will B prime be? If originally it was here at 1, 5, 4 units away from A, now where will it be if it is our new distance away after a factor of 3? Think about that. We dilate, we get B prime, whoa, way up there. And we can make another segment, and check it out. There is 3 times our length, 12, as you probably predicted. And our distance here is also, it's just 12 away from A. Where originally B was 4 units away, and now it's 12. So that's really all we're doing when we're dilating, is we're adjusting the side length. Let's see if this holds true though. So if I go from B prime to C prime, if we're doing the same thing all around, if we're dilating by a factor of 3, then in order for this side to be dilated as well, what must it be now? Our original length for this side here was 5. It was the hypotenuse. Dilated by a factor of 3 should give us 15. It works. It holds. Notice, although the sides are increased by a factor of 3, it kind of looks like the area is a little bit more than that. And that's because we're increasing the dimension of each side while we're increasing the dimensions here by a factor of 3. We're increasing the area by 3 times 3, because I'm adding a 3 over here, I'm adding a 3 down here at the bottom, at the base. So we're going to have a much greater increase of area when we're doing dilation compared to just the lengths. And we can see this also if we go over to geek.com. It is a pretty nifty site with all sorts of tech stuff. It's kind of my thing, so check this out. So here is a diagram of all sorts of TV resolutions. Okay, so you might have an HD TV that is 720p. Here's the original at 640 by 360. If it was at 16 by 9, This is old school. Okay, so you really can't find a TV like this anymore. I think the actual TV that if you have an old cathode ray tube, one of the big ones with the heavy stuff in back, that's like oh boy, like 420 by 300, something like that. It is a pretty low resolution comparatively. If you've got a 720 TV, 720i or 720p, whatnot, that is where the number is from here. The 720 is your vertical lines of resolution, and the 1280 is how many lines you have going across. Well, how many actually 720 is the number of horizontal columns, if you will, that are stacked up here, and you've got 1280 that are going across the bottom. Notice that you've got 1080 here by 1920. The interesting thing about this is that these are also done in a dilation. So if we take this 1080 and we divide by 720, 1.5. That means that there is a dilation of 1.5 to increase from 720 to 1080. What about for 1920? 1920 divided by 1280 gives us also, so you're increasing the dimensions from going from 720 to 1080 by 1.5. This does, as you can see from the picture though, this does not really talk about the area. The area is actually going to be much more of an increase. It's 1.5 squared. So it'd be an increase of about 2.25 times the area, which is pretty significant. You can see some really sharp stuff there. One last thing to talk about. We talked about getting it bigger here. If you want to do a dilation that will give you a smaller, let me get rid of all this stuff here. You want a dilation that will give you a smaller thing, you can go to dilate. We'll take C. This time I'm going to do a factor of 0.5, which would be half. And I'm still going to do it around 1.1. And there we go. C is right there. C is much smaller now. Dilate. Let's do the same for B. We're going to do B 1.5, and again from around 1.1. And we see that is smaller there as well. Again by 1.5. So if we make a new segment, we see instead of a length of 4, we've got a length of 2. We've got a length of 1.5 instead of 3. And then instead of 5 for our hypotenuse, we have 2.5. So if you want to make a dilation that enlarges the figure, make sure that your scale factor is greater than 1. If you want to reduce it, then it has to be smaller than 1. Okay? We will practice this more in class, and please bring any questions that you've got. Thanks for your time, and I hope you have an awesome day.